Hello. Someone suggested that we look at eBPF, and I love eBPF. So let's do something fun with that. When I think about eBPF, there's basically two programs that I've used that use eBPF. So first, maybe for 1 second, like what is eBPF? Basically, eBPF is a language that you can use to spy on what your computer is doing. So one example of a way that you can spy on like what your computer is doing is seeing what files it opens. So if we run OpenSnoop, which is this tool that figures out which files are being opened right now, it's supposed to print out the PID and the command and the file descriptor and the path of each file that's being opened. And this is kind of interesting because I originally thought that this was going to work, and I was like, oh man, we're going to run OpenSnoop. You're going to see what files are being opened. And then I ran this and it didn't work. And I was like, well, that's a bad example, right? Like, why isn't it working? Instead, it's actually kind of fun to see why this is not working, right? So what is this program supposed to be doing? And what is it actually doing, and why is it not showing us what files are being opened, right? Because, for example, if I like run cat on tweets.png, which is just like some file I have, right? Who knows, some image, presumably of tweets. It's OpenSnoop is not showing me that this file got opened, right? And it definitely got opened. So what's going on? So let's actually look at this program. So it's a Python program. And the way that these eBPF tools work, it's kind of weird, but maybe bear with me for a second. So the way they work is you have a Python program, and inside that Python program, so you have some command line arguments and stuff, right, which are like, okay, maybe just trace this PID, whatever. And then inside the Python program, you have a C program. And this C program is sort of like a restricted subset of C, which compiles to eBPF, which is this bytecode language that you can where you can insert these programs into the kernel. So you have a C program as a string inside your Python program. And this Python program is actually going to construct the C program by running search and replace, right? So this BPF text variable is a C program, and this is just doing dot replace filter with this little snippet of C code, right? So this is kind of a hack, but it does work. Well, except that it's not working right now. But I think it's kind of interesting to see what these how these Python programs that are running eBPF are working. So basically it takes the C program and then it inserts it into the kernel, and then it starts getting information back from the kernel about what your computer is doing. And basically what this OpenSnoop program is doing is it's tracing the open system call. This is the sysopen thing here. So let's see what's going on with that. When we cat tweets.png, is it actually using the open system call, right? And the answer seems to be no, right? And so that's a little weird. What I know from experience, because I've run into this before, is that actually in the newer version of, I guess, libc, the way that files are opened are using a different system call called openat instead of open. And the reason I know this is because I think I spent some number of hours being mad about it before in the past. And so this is what happens, right? If we strace, strace is my favorite tool in the universe. It traces system calls. And if we strace cat and look for when it uses openat, you can see it actually is using openat a lot. And at some point it should open, oh yeah, right, the last thing it does is it opens this file tweets.png, which makes sense. That's what we kind of expected to see. Cool. But OpenSoup is not doing that, right? It's looking at the open system call. So what happens? I wonder if we can fix it just by replacing sysopen with sysopenat. So let's try to run it now. And then there are so many things happening. And so we sort of fixed the program, right? This is nice. Uh, Another thing I wonder is if this has actually been fixed in a newer version of um, OpenSnoop. So let's try to find it. If we look up OpenSnoop IOvisor, it's over here. And we can look for sysopen. And it seems like it's actually the same, and that they haven't switched it to using OpenAT. I kind of wonder, like, maybe there's a GitHub issue about this or something. Oh, this is interesting. BCC OpenAT tracepoint cannot get correct file name. So that's interesting. I wonder if this is related to why, like, I expected to see a path name here of which file is being opened, because by itself this is a little bit useless. Like, it's saying that, like, GNOME shell is opening a file, but it doesn't tell us the path of the file name, which, like, kind of sucks. And it seems like someone here is having maybe a similar issue with OpenAT and getting the file name. And I would say that, like, in my experience, this sort of thing is typical, and like when working with BPF, where it can be kind of hard to figure out, like, how to get the exact information you want, like the file name. But maybe we can fix this. Like, maybe we can get eBPF to give us the file name. Well, let's see. Let's look at the man page for open and the man page for OpenAT. No, we want, sorry, that was open1, which is a program, because man pages are in sections, and this is the man page. This is section 1, which is programs. But we actually, I think we want either man 2 or man 3. Yeah, I think we want man 2, perhaps. And so what makes me think that maybe we want this, we need to change something, is that the call signature for open and for OpenAT are different, because OpenAT takes as its first argument this, like, dirfd, like, I guess directory file descriptor argument. And so maybe we could fix our OpenSnoop program by just looking at different command line, like looking at different arguments to the function that's being called. So how does this work? So it looks like here there's this kprobe, and I think so trace entry is the C function that, so this C function gets called every time we it looks like it gets called every time a file is opened. So how does that work? I wonder if I just added an int dirfd argument here. Oops, I need to edit this file. This is a really silly way. I should have, like, copied this program. It's like my home directory. Can I do that? Let's do that actually really quick. Okay, now this is a normal file, and can I just run it? Oh, but I need to run it as root. Okay, great. Now I have like my own version of this program that I can edit instead of trying to edit the version name slash user slash sbin, which is was kind of a silly thing to do in the first place. So, um, oh yeah, my idea here, and actually I'm just gonna add this. Okay. I'm just gonna track my changes to it in Git just so that I have them. So we had this idea to do int dirfd, and I don't really know like how any of this is supposed to work, so that'll be fun. But does that give us the path? It does! We fixed it! We made OpenSnoop tell us the name of the files that are being opened. This is so exciting. Oh goodness. Wow. And so I guess wow. Wow. So we can see that like there's this thing Dropbox is running and it's uh, opening some Dropbox files. Oops. I could where was that tweets.png file? I wanted to see that. Oof. Oh no, there's too much happening. It's too difficult. Okay, what if I just open tweets.png really fast? Then can I see it? Here? It should be somewhere. No. Ugh. Oh, there it is. Okay, tweets.png. We found it. So that file got opened, but there's so much. There's so many other files being opened, that it's hard to see them all. But yeah, so that's kind of life with eBPF. Is it does cool things, but these BPF tools that you can install are like these weird C programs that you write inside Python programs. But you can still sometimes get them to work without knowing too much. So I think we'll leave fun with eBPF at that for now. Thanks for watching.